Three, two, one. Hello and welcome. Welcome back. Okay, so today we need to start doing async await stuff. I really don't want to, but hey, I said that's what I'm gonna do, so that's what I have to do. So, again, welcome back. Let me just check if our audio works, because we had some weird stuff last time. Looks like it works. Cool. If you're watching for the first time, feel free to like, feel free to subscribe, feel free to comment, participate in chat. If you're watching after, this live stream finished, you can always comment. I'll be always happy to respond. And if you're a returning viewer, that's awesome. Welcome back. So we can start like we usually start by looking through the NIM documentation, the tutorial. And let me switch to there. What did we do last time? We did everything in object-oriented stuff, right? Properties, dynamic dispatch, exceptions. Yeah, we didn't do exceptions. So let's start with exceptions then. In NIM, exceptions are objects. By convention, exception types are suffixed by er. The system module defines an exception hierarchy that you might want to stick to. Exceptions derive from system exception, which provides the common interface. Exceptions have to be allocated on the heap because their lifetime is unknown. Okay, so exceptions are on a heap. The compiler will prevent you from raising an exception created on the stack. All raised exceptions should at least specify the reason for being raised in the message field. A convention is that exceptions should be raised in exceptional cases. They should not be used as an alternative method of control flow. That's a good thing to point out. The raise statement. Raising an exception is done with the raise statement. So we have variable e, which is a reference to OS error. Okay, we start with our straight up variable, but it's a reference, okay? This way we can use the new keyword. So we create a new instance of OS error, and we set the message, and we can just raise it. Raise e. Simple enough, okay? If the raise keyword is not followed by an expression, the last exception is re-raised. For the purpose of avoiding repeating this common code pattern, the template new exception in the system module can be used. Oh. Okay, so basically it creates the new error. Yeah, so we basically create new error of this type, and we provided a message, and that's it. Okay, awesome. So I also like this re-raising. Just like throw in other programming languages. Although I wish the what do you call it? Standard library didn't use exceptions so much. I don't know. Whatever. I'm sure it's fine. Okay. Try statement. The try statement handles exceptions. Okay. So nothing special here. We just import the parsed integer. So this will read the first two lines of a text file that should contain numbers and tries to add them. Okay. So we create a variable file. F for file. And if we open the file, so I guess this says true if we manage to open the file. Then we have try block. Okay. Try read line to variable A, read line to variable B, and I guess this just reads to string. And then we just echo the sum, which will be to parse A and B to int and just add them. Okay. So we can cover the overflow defect with the except keyword. So we can do except and the type of error to handle it. And we can do another one and another one. And at the end, we have a catchable error, which will be, I guess, like the, any kind of error that can be caught. Okay. And then we just rethrow it. Okay. Re-raise the unknown exception. And finally, close the file F. Okay. Because this will be run only if we actually open the file in the first place. So that's good. Okay. The statements after the try are executed unless an exception is raised. Then the appropriate except part is executed. The empty except part is executed if there is an exception that is not explicitly listed. Okay. It is similar to an else part in if statements. If there is a finally part, it is always executed after the exception handlers. Okay. The exception is consumed in an except part. If an exception is not handled, it is propagated through the call stack. This means that often the rest of the procedure that is not within a finally clause is not executed if an exception occurs. Okay, that makes sense. If you need to access the actual exception object or message inside the except branch, you can use the getCurrentException and getCurrentExceptionMessage procs from the system module. And here's an example of that. And I don't like that they do that example because it's like, oh, there was an exception. That means I need to create a variable for that and all this stuff. While really in this main tutorial, they should show that you can just provide it here, a room for that, and I will just put that error in there. So I don't like this example here. It's missing this very crucial piece of information. Annotating procs with raised exceptions. Through the use of the optional raises pragma, you can specify that a proc is meant to raise a specific set of exceptions, or none at all. If the raises pragma is used, the compiler will verify that this is true. For instance, if you specify that a proc raises IO error, and at some point it or one of the procs it calls starts raising a new exception, the compiler will prevent that proc from compiling. And there's an example. That's what we use extensively, and that's the thing I believe we'll lose with async await stuff. So we have some kind of complex proc. We mark that it can raise only IO errors and arithmetic defect. Okay. And simple proc raises nothing. Okay. Once you have code like this in place, if the list of raised exceptions changes, the compiler will stop with an error specifying the line of the proc which stopped validating the pragma, and the raised exception not being caught, along with a file and line where the uncaught exception is being raised, which may help you locate the offending code which has changed. Exactly. If you want to add the raises pragma to existing code, the compiler can also help you. You can add the effects pragma statement to your proc, and the compiler will output all inferred effects up to that point. Exception tracking is part of NIM's effect statement. Another more redundant way to find out the list of exceptions raised by a proc is to use the nim.doc command, which generates documentation for a whole module and decorates all procs with the list of raised exceptions. Oh, that's good to know. Okay. You can read more about NIM's effect system and related pragmas in the manual. Okay, this is very good. We need to figure out that doc stuff at some point and that whole effect stuff. Hey, that would be good. Maybe we can check how we can actually generate docs, right? So let's go back, and there were some tooling stuff, right? Documentation, tools documentation. Documentation generator. The built-in document generator, NimDoc, generates HTML documentation. Let's look at that. So this document describes the documentation generation tools built into the Nim compiler, which can generate HTML, LaTeX, and JSON output from input.nim files and projects. The output documentation will include the module dependencies, as in all the imports, and top-level documentation comments. Okay, which is the double hash, whatever you call it, pound symbol or something. And exported symbols, including procedures, types, and variables. Okay. Oh, so the command will be nimdoc. If from that we're gonna get HTML, doc to text will be LaTeX, and JSON doc will be to JSON. So I guess you could use JSON doc to have your own documentation displaying thing, or just for analyzing. That could be interesting. Nim can generate HTML and LaTeX from excuse me. Nim can generate HTML and LaTeX from input markdown and RST, the restructured text files as well, which is intended for writing standalone documents like users' guides and technical specifications. See Nim flavored markdown and restructured text document for the description of this feature, and particularly section Nim flavored markdown and restructured text command line usage for the full list of supported commands. I'll open up a new tab. So nimdoc and then file name.nim, or for the whole project. Okay, so we need to delete an HTML docs file before starting. We don't have that. So let me open up our CommonFS project. I want to see what we're going to get. Come on, open up. You can do it. So we've got our project. And what is the command? nimdoc -- project. nimdoc project. And then we have the git URL, git commit. Index on. Oh, I guess what? This would generate HTML files. The index HTML, index CSS, See also doc root to specify relative root. Let's just copy that. Why do I need to specify git URL and git commit? I guess to have it included in the docs. So we're gonna skip that, and let's just see what's going to happen. So we'll skip the whole git stuff, and file name will be CommonFS. And I don't know if do we need to do doc root to specify relative root. Let's try that. That will probably fail, right? Cannot find the CommonFS. Okay, makes sense. And did we get HTML docs? We got, but it's empty. Okay. So let's try to do src/CommonFS. Oh, there we go. Cannot raise file system error. Just hence right after compilation. All right, let's see what we got. So they suggest that we can really with Python. Let's see if I have Python 3 installed. Oh, I have. Okay. It's running. See all forwarded ports. Sure. And what happened here? There we go. Common FS HTML. We have like normal docs. We got our types, directory, file system, and some of those have descriptions. Look at that. We have our procs here, like create self. We can do 3 dots to see what is being raised. Tags is root effect. Huh. So I click on it. That's it. That's all we get. Okay. So yeah, there's some stuff in here. That's for sure. And iterators are separate here. Very nice. And our index just has all that, right? String, right? So file system R is here. Okay. Procs, iterators, and that's it. And this is everything alphabetically. Okay. All the writes, all the removes. Okay. And do we have anything else? I don't think so. That's it. Hey, that's a start. I just wonder how we can make, work with those comments nicely, what the features are, what features are supported, etc. So documentation comments, any comments which are preceded by a double hash are interpreted as documentation. Okay, makes sense. Comments are parsed as RST. Let's see the reference. Providing NIM module authors the ability to easily generate richly formatted documentation with only their well-documented code. Yep, basic Markdown syntax is also supported inside the doc comments. Yeah, so we have the comment here. And the interesting thing is that it's like inside of the thing rather than somewhere else. So how do I comment just that name or just age? Can you? Can you not? And this type contains a description of a person. Field documentation comments can be added to fields like so. Oh, that's where we do this weird thing when we define documentation for the fields themselves. Non-value stores the number of values. Okay. So I guess I could try that. Let's look at the commands that we used. Okay. Let's stop the server and we use the command nimdoc project, index on, all this stuff. So let's edit our nimble file, okay? Where do we have it? CommonFS nimble. And we have the tasks down here. So let's create a new task. We'll call it regen docs. Regenerate the documentation, and we'll basically do execute. And we'll do all this stuff. But first we need to remove it, right? So we do exec, or maybe we don't. Let's just do the thing for Python. What was it? This thing, Python 3, blah, blah, blah. And we'll just run that. Can we run from nimble? Let's see. So we'll do nimble run, or no, nimble regen docs. Okay, that seemed to have worked. We can go to our thingy and refresh, right? Yeah, it works. So let's look at the type. Something with exported stuff. Let's look at our types if we even have any properties anywhere. Because I don't recall if we have any properties at all. We have to go to the types. Oh, I can't control click. That sucks. Types. Yeah, we don't have anything exported, but we could just add a new type. Something different, right? And we ref object of root object. We'll add a documentation string like this type is just for testing. Okay. And I want to see if I can add a comment to a private field. Some private field integer, and I should do this, right? Oops. The heck? They do it that way? What do they recommend? Yeah, just like that. We can do some private field is totally private. And then we're gonna do a public or an exported field. And we'll do, what's up with those? You two go away. We'll save it. We'll stop everything here. And we'll do regen docs. And let's see if anything updated. We refresh. And do we have our type here? Or, oh, there's something different. What the heck happened here? Oh, look at that. So an exported field showed up like this weird thing. So I guess we can't do the fields, huh? It's kind of ugly. Let's just take a peek if we have anything else defined here. Output directories, index files, document types. No. Documentation links, local referencing. And just all the other compiling stuff. Okay, I see. So it's not super powerful, but you know, it gives us all the basic tools. So it's nice to have that built in. And it will just straight up not show the private fields. So if I would just do that without anything, and the same thing here, save it, regen the docs, and update it. Oh, not this one. This one. Now looks normal. And we actually have the stuff here. But it's being just shown here. This type is just for testing, and everything in bold just shows up different color. Why not? So can I just do here something like a normal comment. Will that show up? Or does it need to be this double thing? Refresh. Ah, normal one didn't show up. Okay. If I'll make it a double one, a docs comment, we'll refresh it. Ah, this one shows up, and we even get like an extra room here. So in theory, we could document those. Okay, that's not bad. It's not a pretty documentation because it's just part of this thing here. But why not? I guess we could do it here. Hello there. Or let's do something like some private field is a private field, an export field is an export field. It also has a docs comment. Can I make a list like that? Regen, refresh. Yeah, so we can just add lists like that. Just normal markdown. No big deal. Okay, I can dig it. As long as it supports markdown, I'll be very, very, very happy. Cool. Okay, so I'll commit some of the code for now because we have an action that works. Okay. Docs regen plus host nimble task. Okay. We have that for the future. And I really don't feel like dealing with the async await. I just don't have brain power today. So maybe I'll shift some gears. I'm gonna change the descriptions. And let's do something else. Maybe we'll continue with the streaming stuff. Where we were making that terminal thingy. Because I have some ideas about improving its performance. Okay. I'll just copy some stuff on the side so that I can have it for next stream. Okie dokes. So let's get somewhere around here. Again, I don't have other links for those. We can just go here. Streaming docs. We actually have a new pull request. Let me just grab the link so I can put it in the thing. Streaming utils. And here we will improve the performance of the Buffer2D that we implemented last stream. Okay. We'll save that. And I have to also update it on Twitch. Improving performance of Buffer2D. Done. Cool. So let's just look what our fellow viewer, Drunken Alcoholic, did. He added the Xconti logo, only the logo ASCII art with the Xconti colors. I'll leave it up to you if you want to use it or not. No code written to echo the logo. But it will look like this. By the way, this is 50 by 50 characters, but we can make it smaller if you want. Interesting. So I guess we pixelated that. And what is the code for that? I guess bunch of colors. Oh, wow. Okay, wow. Alrighty. That is a lot of code. I wonder if we could just write something that takes a picture and just puts it there. We'll get to that later, alright? We'll get to that later. And this whole thing is inside colors, which is kind of, again, not the best because this is more of a constant. So we'll get back there. For now, let's just switch to our thingy. Okay. So what we did last time, we have that whole buffer here. And when we were rendering things, we have this ugly thing in the loop where we create a copy of the buffer, then we pass it to the rendered digits, which, you know, updates the new buffer, and then we're comparing those two buffers to extract differences out of here. So I don't like the fact that we need to copy something, and I don't like the fact that then we need to compare everything from scratch. What I would prefer for us to do is just keep reusing the same buffer we already have, and every time we need to make a change or something, we simply emit what changed and add it to an existing list of changes that we will need to use to update. This way we won't have to copy any buffers, and we'll still have the list of things to do. So let me think. So let's not copy the buffer. The buffer that we'll give to rendered digits will be just the normal buffer, okay? Bam, we don't have a new one. Let's not generate the diff, because this is ugly, going through everything even if nothing changed. We can be smarter about it, okay? Let's have it all inside of rendered digits, or something of that sort. So what isn't happy about? Probably nothing reasonable. Okay, there we go. So rendered digits, where do we have it? Render digits. So basically go over, you know, we were getting the string of the digits to print out, and then we went over lines and digits, and we do all this stuff. So every time we call set, what we could do is that the set that we call on buffer actually returns either like if it changed, like the packet for what changed, and if it didn't, it just doesn't return anything. I wonder if we could just optionally pass it some kind of sequence that it automatically adds it there, so that we don't even have to do anything. I think that would be the best option. So how would we use that sequence? Let's create a separate thing. Do we want a global or not? For the sake of this here, we could have a global, right? Just like we define a buffer here, let's also do var and let's call it a diff. Okay, and that will be a sequence of, and we need to, actually we can check our buffer to what we defined initially. Excuse me. Sequence of this thing. This very, very, very ugly thing. So bam, and we can say that it's an empty sequence starting, right? We start with an empty sequence. T cell, yeah, this will be a rune, okay? So maybe we could avoid this big ugly thing. Let's define it in the buffer, okay? Let's define it in the buffer as the type will be diff sequence, okay? And this will be basically is sequence tuple, and this will be T cell. So I guess we need to define that this is taking T cell. Yep, that should be it. We have it defined here. And therefore, we could also define a diff entry, okay, of type T cell, and this will be just our tuple. This way we can just say that this is a sequence of diff entry. And we will be able to reuse it here. So we say this will be the diff sequence of runes. Okay, that makes sense. And therefore, now that we created those, the sequence for, you know, the differences, that'll be growing and expanding as we have to have it or whatever. While the buffer here, it will just stay there. We're not copying it, nothing. I wonder if passing it as a var copies it or not. That's a good question. I don't know. But in our render digits right here, what we could do is when we set buffer, we can also pass the diff, right? Diff, yeah. And this will be also set, so we pass diff. And do we set it anywhere else? Our buffer? I don't think so. So let's go to our buffer. And when we define set, which is super ugly here. Gosh, this looks so bad. Too bad we have to define all those. Yeah, we will need to say that we have diff sequence, which is a var of diff sequence. Yeah, let's require it. Let's just require it for now. I don't feel like dealing with optionals. This is supposed to be nice and fast. Worst case scenario, we could just, you know, add a variant that's just without it. So this means that self data is this, right? So let's actually do it differently. So when we set it, okay, here, when we set it, we need to figure out the core, the index, right? So we will have let index will be this. So we can just simplify it and say index of that particular cell. And then let value or old value is we just extract it. And if old value is not equal to the value, we add it to the sequence by providing X and Y. Okay. And we update the value. If not, we don't do anything. Okay. And that's it. We just added that change there. Only when there was a change, we actually do something. So that is very awesome. Yeah. Yeah, that makes sense. Okay. I can see that if we would implement something like double buffering or whatever, then it will be a little bit different, but we're not doing crazy graphics engine or something, so this should be good enough. Because, if we're having like, where we're printing lots of things that overlap to our buffer, basically every frame we try to print some set each some of the cells multiple times, we're suddenly running few extra instructions, we're adding those to the sequence and whatnot, and it just gets bad. But in our case, let's for now focus on the fact that we won't be copying a buffer, because then with the sequence we could actually make it so that maybe instead of x and y we actually set a proper just index, because that could work. And then this could be a hash set depending on an index and all this stuff, just to reduce the duplicates. There are possibilities, but let's start with something simple. And then here we have the auto setter that has just an index. Why are we providing x and y in the first place? Oh, because we need to know where to place it on the actual, what do you call it? In the terminal. That's what it is. So here we need to basically extract the let x is index mode width, sure, and y. What? How the hell do we extract that again? Let's do it here. We'll make a simple proc, and let's actually do it after this. Let's be proc pause to index. Okay. On the buffer itself, and this will be we provide x and y, and it returns that. And we just want to signify this is in line. Okay. And then we have the other proc index to position, also in line, and I will return x and y tuple. Okay. Do we have equals at the end? Yes, we do. So index mod width, that'll be the x, right? Yeah. Well, index divide by width. Yeah. Oh wow, that actually is very simple. Wow, I didn't realize it's that simple. Cool. We've got those two. So let's just use this somewhere here. This will be just the self dot post index x and y. Okay. And this should just inline it. And then yep. And then we're going to do same thing here. And do we have one more somewhere here? I don't think so. So we can just do it here in the reverse. So we'll do let x, y is index position, and we just provide it with the index. Okay. So the all value is here. And if these are different, so we don't need to calculate it yet. We need to calculate it only if we actually have a different value. There we go. We just add it to the sequence here. Okay. Yeah, that'll be it. And we'll get rid of the whole diff. We don't want it. We don't need that dead code anymore. So let's go back here and our code should be happy. Because where are we setting things? In our rendered digits, we just provided with a diff. And then when we're rendering things, display the message. And then what? Minutes, seconds, calculate time, countdown time, color section. Color section, yep. Selection, sorry. And we render the digits. That's what we did. Oh yeah, we render them to the buffer, and then we go for each element of the diff of that sequence. We just do that, so we don't even need to make any code changes here. The only thing is that we need to remove them from the. We need to remove those elements from the diff. So to make a copy, that would be kind of not fun. Let's assume that nothing is writing to the buffer or whatever while we're rendering it, okay? So we have all that, and we can do basically that the diff is a new sequence, okay? And that should be fine. So if this is correct, that means that we'll be able to easily just run the whole thing and be done with it. And let's see. Error, iterators, the length of the sequence changed while iterating over it. Oh, that's the thing. So look at that. We did the for loop over it. At the end of the loop, we did. Oh, wait, I need to. After the loop here, because that was a loop for each element. It's good that compiler says that, hey, the sequence changed while iterating over it. That's, for example, something you could do in C#, and because of that, you can have very strange errors. Hard to track. Okay, there we go. It's printing it out. The first one always goes slow. We could probably time it now that we know how many changes there are. We could time it so that it actually manages to print things in time. Let's do that. Let's make sure that it prints things out in a decent time. So no more character delay. Okay, let's skip that. And basically our sleep will be 1,000 because we want to. Oh, yeah, 1,000, sure. This is time elapsed. So let's do something like here. Calculate time and whatnot. We have call section rendered digits, and by this time we should have how much time, how many changes there are. So let's do let character delay will be diff.length. That's how many we have. So let's do 1,000 divided by this. And that should be it. And what next? We just printed out. Time elapsed will be incremented that, and whatever was left, we just delay by it. Okay, that will be again a really easy change. And I have a habit of turning that off. Ay, ay, ay. Look at that. Make sure some of them go fast, some are gonna go slow. Huh, this is fascinating. Cool. So now I have another interesting idea. Let's commit those changes, okay? Because we just optimized the thing. So let's see. What did we change? In our countdown. This is not the thing to. This basically delete the file. This is a binary. Binary has been committed previously. Interesting. Okay, buffer. We have our buffer. And yeah, we did a bunch of stuff here, so that's the good thing. And countdown. Yes, we did more stuff. Nothing super, like, unnecessary here. So let's do optimize buff diff gen. No more buffer copying. Okay. And we push it. Great. So that's one thing that we did. So now I'm wondering if we can get like info about the dimensions of our terminal. So maybe instead of, like printing like to a normal thing, we could straight up kind of wrap it around, make a wrapper around, printing. And we could, do something more interesting where we just straight up get the size of our terminal and have a buffer generated on that, depending on that, and we just have a buffer of the whole screen. I would like that. So let's look at the docs. Let's see where the docs will get us. And let's get rid of this and let's go to the docs. Standard library. We had that library about terminal somewhere. Was it somewhere? Terminal. We have foreground, background color, foreground color. Okay, some predefined colors. Okay. Style, bright text, dim text, italic. Huh. Could be fun too. Terminal command. Commands that can be expressed as arguments. Okay. So ANSI background color code. And it just generates it from the color. Okay, so we already have those kind of here. Cool. Cool. This is fun. Cursor backwards. Move the cursor backwards by that many columns. Huh. Down, forward, up, all those little things. Enable true colors. Erase line. Okay, so we have erase line and erase screen. Cool. Get character. Reads a single character from the terminal. Blocking until it is entered. Oh, okay. So this is basically like, if you want to capture whatever is being written. Okay. Is ATTY. Okay. And is true color supported. Let's print it out. When we start out, let's do something like echo true color supported. And we do we need to provide something? No. Is true color supported. What if we're gonna run it? Oof. We cleared the screen. So let's do exit or quit. And program, whatever. We should be able to run it, right? True color supported false. How about here? False. I guess we don't have true color support. Good to know. Read parser, read attributes, blah blah blah. As all attributes and huh. Cursor position, reset attributes. There it is. Terminal height. Turns the terminal height in rows. Terminal height IO CTL IO control. I guess we can ignore that one. Terminal size. Oh, that just returns width and height. Perfect. Write style, write the text, txt to give us and a given style to std out. Okay. Style right and unseat blah blah blah. Oh, so I guess we could check from time to time the size of the terminal. And this way we could react if it's resized or something. I guess that's how we could do it. So we got the terminal size, right? Terminal size. Yeah. So let's make our own little module. We'll call it terminal. Okay. And what we're going to do is we're gonna remove the terminal, the standard terminal from here. And we're gonna plop it in our own terminal. Import standard terminal. Okay. And we would need to have some kind of object terminal that we can just pass on. And this way we can keep track of things happening. It's kind of object-oriented approach. But that's what I'm used to. Yeah. In theory, there's only one terminal anyway. So yeah, let's just have it like global things, okay? So goes to variable and it'll be size, which will be a tuple of 2 integers, okay? And we'll do -1, -1. That's what we start with, okay? Let's do like proc for any terminal. Oh no, we don't have to because the code will just run. So let's just do initialization code. Okay. So we do that. The size is terminal. Wait, it'll be terminal size. That's what we should be able to do, right? Terminal size. And we don't pass it anything else. It just returns stuff. Okay. We just need to make sure that we import terminal. There we go. And ported but not used. Okay, that's good enough. So then what else were we doing here? We were doing set cursor position and styled right line. And what was styled right line? Macro styled right. And there's no styled right line. Styled right line. There we go. There's styled right line. And that's a template. Yeah, it's a template, huh? Okay. All right. So that's a template. That uses styled right, I guess. Can I see the source of that template? What is it doing? Styled right line. Okay. Runnable examples. Don't care. So it does styled right. And then it just writes empty line. So it's literally styled right. Okay. Okay. Our styled right is the more interesting one. Macro styled right. And there's a bunch of stuff. For and counts and blah, blah, blah. Yeah. I'll assume it works. So styled right is something we can use to just keep writing, I presume. Okay. So let's look at examples. Let's just get rid of this. Because we had those examples somewhere here. And styled right line, it's just that. Styled right. Styled right line gets the list of those var args, while styled right also takes that. Okay. Okay, makes sense. Similar to write by treating terminal style arguments specially. When some argument is style, set style, foreground color, background color, or terminal command, then it is not sent directly to F, but instead corresponding terminal style proc is called. Okay, awesome. So that's good. That means we could, in theory, use our own ones instead of passing strings, I guess. Where is it like set style or something? Set style. And what is a style? Style is just a value here. Okay. So we can just set style and set foreground color, and we just give it the color. And additionally, bright, true or false. Okay. Well, let me try that. Set foreground color and do all this stuff. So, terminal. And let's do it here as a little test. Tuple for terminal type, about expected tuple, integer error type. What? How is that wrong? Oh, that's why it's wrong. Okay. Bum, 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 bum. Can I just do that and ignore it? I guess it's fine now. So let's do something like echo, or what was it? We want to set this. So we use right. Right styled is when we set the style. Okay. So that's fun. Yeah. Then we have right style. That's text and a style. Okay, so that's it. That's without the color. Okay. And I guess it just sets the style temporarily, I'd presume. But didn't we have like a normal right? Or we just do standard out right and we'll do whatever it is here, right? So this is the default style. Then we're gonna do something like this is the, let's do bright color. Okay. Ignore all those, and we'll just have the out. This is normal color. Okay. We'll just try to make those little things here. Okay. Let's assume that these will be right. And here, we're gonna just straight up ignore everything else that happens with the file. Ignore temporarily. Okay. And therefore, we'll just do quit. Done. Okay, so we can do, yeah, this should just happen automatically. Because we imported terminal. So what happens when we try to compile it? Run it. Failed where? In terminal nim. Bum bum. And 325. How is that style suddenly not being accepted? What the heck is this? Will it run now? Was the complaint? What on earth? That's how you set tuple. The size? Is it complaining about that? Because that would be the strangest thing. No. What the heck? So I must be doing something inherently wrong. How do we use tuples in here? An array. We used tuple just like that. And we could define it here, right? And how do we create one? Just like that, no problem. What the heck am I doing wrong? X and Y. Now it doesn't complain about it. That's a new one. Got tuple this and that for thermostat, but I expected tuple. Oh, W and H. Okay, that's true. W for width, H for height, and that should be it. Okay, good. So build failed because unreachable statements and everything. Okay, so let's take care of it like a little bit more properly, I guess. Can I just shove in a comment like this and just comment everything out for now? Because I want to test the damn thing. What's gonna happen now when I try to run it? What error this time? Okay. Did it fail to build? No, it didn't fail, but at the same time, it didn't execute our code. Why not? Because we didn't import anything after all? So let's do proc. Let's just do proc test terminal, okay? And that will be it. We just do that, and it will contain the basic code. And therefore, the size should be executed, I hope, or we'll figure it out. And save. We'll just export it here nicely. And we can do test terminal. Okay, will it run now? No. I guess printing out to standard output doesn't work after all. What the heck is going on? Right line, right? That should print out as well. I think that exists. And that works. It's as if the terminal waited for a new line to print anything. Okay, this is strange. That's different terminal file as well? Yeah, this is new. Hello, Drunken. Nice to see you back. I know I'm waving back 10 minutes later. As I can see you're back, I can tell you what I started doing because I figured I'm gonna make some changes. So last Friday we did make the buffer, right? We made the whole buffer. And what I did is, let me actually get to the, do we have it here? GitHub. There we go. Why does it change it? Okay, so let me show you the latest commit. So we had this, there we go. So in our countdown right here, we had this one part that I didn't like, and it's not showing it? What the heck? Oh. No, it's not showing it. Oh, here. I'm looking wrong screen. We had that part where we where we copied our buffer, like every frame, we copied our buffer, we rendered the digits to the new buffer, then we compared them to, okay? We compared them to have the list of differences, and we replaced the old one with the new one. And then we went on and printed the, we updated the differences. So this, in theory was more optimal, but I didn't like that we are copying the buffer, okay? And then so basically, the program needs to copy it, therefore iterate over everything. And then we're actually, after we printed out the changes, we needed to go over everything again and make the differences. It's like, wow, this is just so much. So what I did is that when we're setting the stuff, when we call buffer set, we also need to provide it with an instance of a sequence of the changes. So only when we set the specific cell in a buffer or whatever, the pixel, only if it changed, it actually already instantly adds the change to the buffer. I mean, to the like different sequence. Therefore, down here, we don't need to copy the new buffer. We just render things to the existing buffer. And because we, the differences are generated instantly, we don't even need that difference anywhere. And we just print them out. So from the buffer perspective, not a lot changed. I just added like little types for the diff entry so that we don't have to retype this ridiculous thing every time. And the same thing for the whole different sequence. I made a little helper procedures to convert position to index and the other way around. And we basically updated the set so that it actually gets the old value, checks if it changed, and only then it actually updates the buffer and it actually adds to the diff sequence. And that's all we changed here. And on top of everything, I was upset that some things, when we have a lot of changes, they render for a long time. So I made it that initially, when the frame starts, which is somewhere here, whatever, when we render the digits, we know how many changes we have to the buffer. So we basically take 1,000 milliseconds, divide them by the number of changes that we need to make, and therefore we have how many milliseconds we need to wait between each character changes. And this way, the changes will always happen within 1 second. and therefore we don't have any delays and it just looks pretty. So that's the change I made so far, and now I'm doing crazier stuff, which is I'm creating my own terminal nym, and I'm getting really upset because if we do standard out right, it won't show, but if we'll do right line, it will show that we wrote a line. So this is upsetting. Like, this is right, it doesn't write anything, while right line, it writes the stuff. So what the heck? Because we can't just write to the terminal. We need to add the enter at the end. So we need to move the cursor like crazy. Very strange. I wonder if that could be reported. Yeah, let's do that. Let's submit like a issue to the nym stuff. Though, where do we do it? Where does the standard library live? Let's go to nymlang.org. Okay. And source will just takes us to GitHub, right? So here on GitHub, do we have like a, because this is the nym language, right? The whole thing. Nym is statically typed, blah, blah, blah. We have nym suggest, we have testament, nym pretty, nym docs, everything's here. Lib, is that the library? Pure.js, standard library, there we go. Okay. So let's look at the issues. If there is something with line, I'm sure there will be a lot of them. 312 open ones that have line in the name, so, or somewhere. Right line. Oh, there's 6 of them. Storage access, split. Okay, okay. Okay, closed. Summarizing this doesn't run. Generics lacks new line. Okay. Expected double new lines and standard error on Windows. Okay, we don't care about that, but hey, nothing like that here. So let's create a new issue. Bug report. So a title, okay. The standard out dot write doesn't print. Hello, Kremik Bananowy. Nice to have another viewer. How are you doing today? Am I creating CommonFS right now? Actually not, because I feel very uninspired and don't want to deal with it. I'm submitting a issue for nym language because for some reason, when we do standard out write line, it prints it out. But if we'll do it like this, it won't print it out. Although I wonder now, if we're gonna just write this and then write line this, if it's gonna print them out both. It's another edge case to test. Yep, so it prints it out, it just doesn't display it until the enter is hit, the new line. Go figure. I'm glad you're doing well, Kremik Bananowy. Banana cream. It's an interesting, another interesting handle. We have the drunken alcoholic and the banana cream. All right, so we've got another info for the thing. What if I'm going to do standard out, std out, write, and I just write that, okay? What is going to happen? Let's just actually do it as a character instead of the thing. Run it, and now it works. So we need to write this character to even get anything to what the hell is going on? Why is it that way? I don't recall terminals working that way. Something about standard out buffering. It might be, but why? Because the whole program is finished, yet it didn't print anything. Flush buffer. We could do... I don't really know. Standard out. Do we have something like flush? But doesn't it just straight up remove it? We don't have... Whoa, I can't spell. I don't know if it has a function like that. What is standard out in the first place? I'm sure it's defined somewhere in the standard library. Let's go here, standard library, and search for std out. Sync.io, std out. Standard output stream. It's a file, okay? And on a file, what can we do on a file? File handle, flush file. Flushes f's buffer. Okay, we should be able to do that. And yeah, it just removes. No, it's just still there. Okay. I guess when we call it, by that time, it already written it or something. So it writes it, but it doesn't display it. So it must be something with how terminals are displaying it. This is so strange. Let me think. What if I had a terminal that, because the way I'm running it, it's on WSL2. This is through VS Code. And this is the, whatever, what do you call it? Forgot what is it called. This is, well, that doesn't help. Tabby terminal. What if I'm going to get the normal Windows terminal and connect to WSL2? Okay. Repos to streaming and then countdown. Okay. Let's make it massive and nimble run. Same thing. I'm actually tempted to try to run. It's like a separate, because WSL allows you to just run terminal, but I believe because this is running on Linux, this is Linux GUI, I should have a terminal here, right? ls. I just can't make it large. CD countdown. Okay. Nimble run. And I have the same behavior. Okay. So no matter where, I have the same behavior. Yeah, write line adds a new line at the end. And therefore, we have this, and then it prints on a new line. But the problem is that if we have just write and then we don't do anything else, it won't write anything. Exactly. So look at the code. In the code, we can define, because that's what I wanted to do initially. that I write this, and I write that, and I write that. Let's add spaces at the end, okay? So I wanted to just write one long line in the terminal and then exit the program. So when I run that, the only thing I'm getting is absolutely nothing. Nothing is printed. Nothing. After all the warnings, there is nothing printed. Only when I make the last one, like, I print literally a new line symbol at the end, everything would be printed. Bam. This printed, and that printed. So this is the weird behavior. I did a lot of stuff and I never seen it work that way. Because that means there's no way to print something and have the cursor stay here while maybe a few seconds later you're going to continue, like when you're making a progress bar or something. And because of that, few other things don't work. And if we need to keep moving the cursor non-stop, we're just losing performance. If we want to do, print fancy stuff. So, in my opinion, that's a bug that I need to submit. Doesn't print to terminal until new line symbol is sent. Okay. And that'll be it. So what can we say about it? Nim version. Let's get my nim version. Nim. Come on, terminal. What the hell? Nim version. Nim compiler version 204. Okay. Let's just get the whole thing. Nim version. Okay. Current output, expected output, possible solution, additional information. Okay. So, wait, it disappears when you resize terminal. It's right here. It just stays there. So, everything works as expected in a way of terminal. So, okay. And the std out dot write doesn't actually print out to the terminal window until the new line symbol has been written. Because of that, it's impossible to print something to terminal output without moving the cursor to the new line. And we can give an example, right? So let's do it like this. Nim. And let's get our... Let's actually make this example here, the way we want to present it. So this will be whatever. Right, 1. Okay. And then we do sleep. And we'll do 1000, okay? Before, okay, the Kremik Bananova is saying No, before you've added the /n, it was visible. When you resized the prompt, move to the right and it disappeared. Move to the left and disappeared. I'm gonna check in a second. So we just sleep, but I need something special for sleep. There's no way I would need something special for sleep. Come on. Sleep. Where's sleep? Oh, I need OS. Okay. Import OS. Okay, so we can sleep. Then we can do 2 and 3. And then something and something. And that. So we do 1, 2. Let's just do numbers, okay? Because this should be simple enough. Okay, 1, 2, 3. Then we do the new line symbol. Okay. And after new line symbol, we do 4. So let's do it as a string. Ha. That'll be 5. And then we'll do 6. And then we'll finish it off with a new line symbol. Okay. This will be our code. We'll save it and let's run it and see what happens. Nothing. 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 Oh, 1, 2, 3. And 4, 5, 6. So it didn't show that, didn't show that, didn't show that. Then it printed this. So that made show 1, 2, and 3, but didn't print 4. Only when we encountered this one, it printed 4. So let's do terminal is nothing. Okay. Nothing, nothing. Here will be 1, 2, 3, and nothing. And then it will be again this and that. And then suddenly we have 1, 2, 3 /n 4, 5, 6 /n. No, actually it started a new line earlier, right? As far as I know, yeah. Okay. And we can resize the terminal while it's running. Nothing. Yep. Resizing terminal didn't do anything. We can do the same thing where we try to resize the terminal while it's running and nothing. Yeah. So that's that. Let's just do this. Okay. And our, where we started it here. So we have our code, okay. Current output and expected output. Yeah, let's just add on the details. Like in the beginning here, platform Windows 11. OS will be Windows 11, WSL2, Ubuntu. What the hell kind of Ubuntu do I have? Ubuntu 22.04.3. 22.04.3 LTS. Okay. That's the thing. So I'll just shove it all the way at the top because that's helpful, I believe. Doesn't actually print out the terminal window until this new line symbol has been written. Because of that, it's impossible to print something to the terminal output without moving the cursor to the new line. and we basically have this thing. Let's do write one. I don't know, current output. It's kind of pointless right now. Expected output. Expected or yeah, let's just do this whole thing. Let's put the current output here, okay? While expected output will be here. We expect it to show 1, then 2, then 3, then we expect it to be this, and should be 5, and should be 6, 5, 6, and then we have the whole thing. Okay, possible solution, no idea. Additional information, don't know. So okay, but another says that he rewinded the stream and for some reason it was visible for a split second. Well, for some reason it doesn't want to show up here, so I don't know why. It makes me upset. And I close my terminal again. Every time. Yeah. Doesn't show anything. It's just waits. Well, this should be already 4 and 5 here and everything. Ugh. What if I'm gonna write something similar in a different programming language? What about that? Let's just do that. We're gonna remove all the comments. We're gonna just grab it. And did I copy it? Come on. Because I want to see if other languages have the same problem before I do something here. So let's grab our ChatGPT and quickly, please generate an equivalent code in Go. Well, whatever. Here's some code in nim program. Whatever, in nim, okay? We've got this. This is really straightforward. Write an equivalent in Go. Okay, let's see. Well, the thing is that I shouldn't supposed to call flash file to see the thing from std outright to see it on the screen. That's the main thing. It doesn't work like it's supposed to. Okay, so this is my Go file, right? So let's copy it. Let's just go to here. We're gonna create a new little file. A new file, test.go. Okay, we'll just paste it and let's do what will go. Wait, src, and we have our Go file here, right? Run test.go. Come on, Go, not found. I don't have Go installed here, seriously. Zig version. I've got Zig. Okay, great. Now in Zig language, please. Let's see what it looks like in Zig. I'm curious. So import standard. We do that. We print 1, we print 2, we print 3, and we just print them, and we just sleep in between. It's very, wow, we really sleep in nanoseconds? Holy moly. Okay, I guess Zig tries to be really precise. Sure. And what's all the dot thing? What are those? is to pass formatting arguments to the print function. Oh, okay. Okay, makes sense. So let's copy that. And how do I run a Zig program? Main.zig. And we just have that. And Zig. EXE, seriously? How do I compile and run Zig program on Linux? Not build exe, unless build exe is just executable like generic. So let's do another file. It's new main.zig. We paste it here. We have it saved. So what do we need to do? Don't care about installing it. Okay, zig this and just run it. So build exe main zig error. Error is discarded. Oh no. Now we have error handling. Oh, great. Hey, I heard Zig doesn't have a bad error handling. It's just I don't know Zig. Oh no. There's a problem with error handling in the program you wrote. Zig. And let's just paste it, and there you go. Okay. Put that. Oh, there's an exclamation mark, right? About errors. I think that just says that there can be error thing, and try means that we're suggesting that we're handling the error by putting it here. That's, I think, what it does, which is a very strange approach, but hey, people like the language. And okay, it builds. So we do main 1, 2, 3, 4, 5, 6. It worked as it's supposed to. Let's see the other terminal. Let's go to source. Let's make it even larger and do main. Yeah, it prints out like it's supposed to. That's what I wanted to work like, but for some reason Nim isn't happy about it. So confirmed, other languages work. Let's just do this crazy thing and call it that it works on with Zig. Okay, so we go here. The equivalent in Zig works properly in the same WSL2 environment. And we just provide the code just to provide more info. Okay. And I think that'll be it. Yeah. Submit new issue. There we go. Our first contribution to Nim language by complaining something doesn't work. Oh well. For now, let's just assume that it all works. Let's get our Zig and Go files. They shouldn't be here. I wonder if Nim could use Zig to compile C. If that would be an improvement. Huh. Because many people use Zig compiler or like Zig to compile C, to be honest, which is another crazy thing. Okay, so now our terminal. How do I make... Hey, what if I'll write my own quick wrapper about writing? Right. Okay. And we'll just give it We'll just give it a string, right? How the hell do I specify those arguments? Right, args. I'll call it segments. Okay, or strings. And it'll be for args. We do string and we want to specify this thing, right? We just do right. And at the end, we need to do standard out right this thing. But how can I get back in the terminal now? How can I do that? Does the terminal give me an option to go back? Let's get back to our standard library. Or was I was maybe here or something? Nope. Standard library, and that was terminal. There we go. Can I get current cursor position or something? Cursor backwards, cursor up. There's set, but there are no gets for the cursor position. That sucks. I guess we can't get it because in theory, standard out is what? Just a stream. So it wouldn't make sense. I guess we need to stick to normal rights and just for now deal with it that it doesn't work. I should actually just realize that in this issue, I need to specify that other things that depend on it don't work either. Edit. And we just... okay, let's actually do that. Let's move that. And let's just do operating system. Okay, Windows 11, blah, blah, blah. Current output. And that's so the issue we can also say, procs and macros that depend on writing to files have the same issue. Oh, depend writing to, not to files, to standard output, okay? Have the same issue. For example, and that's in our terminal, right? In our terminal, we have something that didn't work, and that was right styled. Or styled right, yeah. And can I get like a link to it? Copy link address. There we go. For example, styled right. And standard terminal. And we just do here. Style right. Okay. We just give an update that other things don't work either. Cool. So we can get the cursor, we can do stuff around it, so we can just focus on the basics. So I wanted to be able to have this size, and this won't work here, so I don't know, whatever. so we don't worry about our testing terminal. The thing I wanted to do is to basically have it so that our terminal thing knows the size of the terminal and basically maintains buffer for it automatically, and the whole diff and whatnot, and therefore we should be able to have, like, you know, abstracted away dealing with the buffer. So what I could do is take stuff from here. We just uncomment our code. Okay. So I need the buffer and a diff sequence here. Okay. I need that. So in our terminal, we have the size of the terminal, oh no, now the buffer needs to be specified dynamically, depending on the size of the whole thing. But if we would make it a sequence and we never change its size, and normally sequence will be on the stack as well, right? Unless we make it a reference. Kermit Banova says, I think that it's not a bug, it's a feature. You're using low-level IO procs, so you have the buffer in full control. Zigprint is probably not as low-level, so it flushes at the end. I mean, I can just modify the example, and I'm sure the flush won't do anything. I mean, standard out is just a file, so when I'm writing it to a normal file, I can probably check that out too. So yeah, let's try that out. We'll try the flushing, and we'll try the other thing. So let's copy the code that we submitted to the, where is it? To here. Okay. We copy this code, we paste it. And let's just do standard out.flash file, okay? And we just call it after every single write. Save. And let's run it. Undeclared Buffer2D, what is it trying to do? Let's comment everything else out. I should have created a separate file for it, but I guess I'm extremely lazy. Yeah, now it prints out. So flashing file after every single one works. But I don't want it to work that way. That is so annoying. Then how do I write to it? Like, what the heck? I don't like that. I do not like that. But you're right, Kremik Bananowy. So let's do this and add this additional info there. That this works for some reason. But why is this new line symbol suddenly making flash file and that it shows up? That's another inconsistency. Edit, and let's add at the bottom. The flash file proc makes it work as intended. And we've got it here. There we go. Okay. Good enough. Cool. Update comment. There's a little bit more info to whoever will be taking it on. so if that works, that means we can make our own right for some reason. Yeah, I guess. I don't like it. I really don't like it. So, in our terminal, we just uncomment everything. We need to import buffer. Yeah, buffer. And in the meantime, we can do the same proc, right? Proc right, and we'll just make it, what do you call it? You're saying that it's probably standard POSIX behavior from 50 years ago. Possibly. That's the thing. I don't like low level that much. That's why I went with something like nim, not zig, because zig is all low level, while nim feels a bit more high level. Apparently in Unix, a new line will typically only flash the buffer if standard out is a terminal. If the output is being redirected to a file, a new line won't flash. I guess closing the file will flash the buffer. I presume that sounds logical. So as long as you close the file, you actually wrote to it. And probably no, like files on a hard drive work differently when you send stuff to it. Probably try to do it as soon as possible or whatever. Maybe until its own little buffer works. Whatever. Don't know. I feel like I shouldn't care about that to write software that works. So strings will be again, that will be the var args of string and the operator here, and we just do this, and then we need to do standard out flash file. Ew, so disgusting. So let's make a variant of that just a text string, and we just do write and flash file. Okay, we have those two variants so that we can just write and be done with it. Okay. I guess that's the way around the problem. Yeah. Yeah, or had the buffer size, yeah. Yeah, I wouldn't want to set the buffer to 0 because, yeah, I usually want to write a bunch of stuff and just wouldn't want to worry about flashing a file, But at the same time, yeah, because that's why I made the separate write. One is when we just write a single thing, and the other one is when we write a bunch of stuff and we flash only after we wrote it. You know, after we printed out the whole thing. So yeah, that's that. So I wonder if we're gonna get a lesson in that bug report and that issue on GitHub. Curious. Okay, so getting back to this, we need buffer. So we need to make our buffer not be a... Oh, that's gonna simplify it so much. Because we don't want our buffer to be a nice array. We can make it actually into a sequence. That means we can, you know, redefine it, whatever, and it will work. Awesome. So let's do it like that. We don't care about specifying this anymore. Bam. And this will be a sequence of that type. Bam. Oh, so much better. Yes. So we basically everywhere where I have this, I just get rid of it. Oh, it feels so good. Oh my gosh. The same thing, Buffer2D, we need to provide it with width and height, but not in a type. So go away, bam. Oh, so nice. So now, yeah, I don't want to be able to change the buffer, the size of the buffer after it's been already created. So I want it to be width will be integer. Okay, let's just make it W, and we can make W comma H with an height, right? So when we ask for it, okay, we're gonna just return self.w and self.h. And therefore here will be self.w. Okay, let's just copy and paste it everywhere. And that's it. We just changed it to a sequence and bam, that's it. That was easy. Yeah, let's not even worry about some bunch of stuff because this would need to be set somewhere when we create the buffer. But it's gonna resize itself, and maybe initially will be a little bit slow, but after a while it's gonna be fine. So I don't want to worry about resizing it, worrying about that too much yet. So that's that. We have read-only access, so that's great. And therefore, when we're creating it, oh, we will need to specify the size, right? Huh. Because we can't specify it here, and yeah, it needs to be set. So proc init buffer 2D, and of type cell, we need to basically width and height as integers, and basically we make it that we have a we need to return the Buffer2D. But what if I want to just create it or something? Because I recall that there's, let's just write it quickly. So we have the var. Can I delete buffer2D, and this will be the T cell. And we do this and that, and the sequence. How does creating sequences work? Can I just provide a size or something? I don't think so. But it should have all the elements of the sequence. The sequence already should have all the elements created. So let's just make this happen here. Okay, so we'll do var buffer. Buffer the data is this. Let's see if we have anything in a sequence. First of all, I'm gonna go here, go back to wherever I was, and let me just check the tutorial again. Where's the tutorial part 1, sequences? Do we have anything about creating sequences? Basic types, advanced types, sequences. Okay, we can create them like this, right? But what if I want to have like a nice big sequence? Not here. Let's ask our specialized ChatGPT. Why not? My GPTs, and let's get the Oh, I can delete that one. Delete. And the master. How can I create a sequence with a specified number of default elements in it? I don't want to call add so many times because that would be kind of yucky. The new sequence procedure. Okay. Sequence with specified numbers of elements. So we sequence and just like that. Let's try it. Is new sequence T cell, and we just do width times height. Hopefully that's gonna work. This way we'll have this, and we just do yeah, let's do result is this, and then we do result data. And we don't even need to create anything. It's just straight up the thing that we're gonna return. There we go. So that's that part. So let me ask another question, because I don't want, I mean, I don't know if we're kind of creating a new buffer here, right? Doesn't mean that when we return it, we kind of create yet another copy. Oh, new sequence of cap, says Comic Bundle of it. That's a good one too. Let me search for that one, because I want the docs on that. New sequence of capacity, okay? New sequence of capacity. Okay, new sequence of type with length 0 and capacity cap. Oh, see, that has a length of 0. That means there will be no elements in that. And you're deleting your message. Oh well. Sequence uninitialized. What other types? New sequence. Because it's at length of black, but more efficient since no reallocation is needed. Awesome. So that, okay, that straight up creates a proper size. Will be filled with zeroed entries. Awesome. But what is the set capacity on it? Because I would like to set a capacity on it that's exactly the size of the sequence. Or does it do that already? So let's see the source of it. What it does. What does it do? Of course, we don't get implementation here because it's magic new sequence. Oh well. It should be good enough, right? No worries, Kremik Bananowy. You're somewhere in Poland, I presume? Considering your what the hell do they call it? Not nickname. Login, your handle on YouTube. All right, so we have it set, all good. So, so basically I wanted to check if we can make it, you know, give a hint to the compiler that this should be not like copy return or something, that it should be actually something else. So let me get to our chat again. So let's give it this thing. I have the following code. Okay. I want to make sure that the Buffer2D is returned without needless copying. How can I do that? Well, needless copying and without using ref. Okay, just to make sure. We'll see. It says, yes, Województwo Śląskie, and you? I'm in the US, in the state of Georgia. It's nice to have a viewer back from Poland. To ensure to return news company without ref, you can leverage names move semantics. Oh, geez. Using the sync parameter can help avoid unnecessary copying by transferring ownership of the data. Additionally, using the lent annotation for return types can help optimize the return of complex objects without copying. So, what's the change here? Nothing changed here. Nothing changed here. Nothing changed here, and nothing changed here. Okay. I just read about this whole land and sync, but I guess this is compiler will figure out. Even better, we're gonna mark it as inline, okay? So maybe the compiler will be able to optimize the hell out of it. Okay, so we've got our buffer initialized and ready for sequences. So now our terminal.nym can contain a buffer, okay? And we can just say that it's of that type, okay? And yeah, it's of that type. That should be good enough for now. And the sequence of for diffing is just here. When would that code be run, I wonder? So the buffer is this. And okay. This isn't happy, has no type, or is ambiguous. What? Oh. Duh. Init buffer. Okay. And do we have it exported? Yes, we have init Buffer2D. That's the thing. Init Buffer2D. Okay, we specify that it's a rune, and for rune we need Unicode. That's another thing it's complaining about. Okay. The generic arguments are missing. No, that's probably an old error. Okay, so that's good. We write this and that, so that's good. And ultimately we'll add this whole write thing so it doesn't write to our just to standard out, it'll write to the buffer, okay? But before we do that, let's make sure that we can kind of iterate over everything, right? Because if we want to print out, maybe it would be nice to have an iterator over all the things that we need to do. So the diff would need to be created as literally everything from the buffer initially, right? That everything changed. Or maybe not, because what we can do is clear, what was it, in a terminal. Open arrays and whatnot. Let's use the first one for terminal. Standard library, terminal, there we go. And we do clear. No clear. Erase screen. Okay. So we do standard out, erase screen. Okay. We'll just call this. And yeah, that should be it. That should be the end, the thing. So therefore our buffer initially is empty because our screen is empty. Hell yeah. Okay, and yeah. Sounds good. So I would like an iterator. Iterator. In theory, we could just write a whole thing from scratch, but let's just keep it simple. So what's that app that I'm browsing the docs with? Oh, that's just a browser. It's the Arc browser. Arc browser. Okay. Arc browser. And I don't know, it's a browser for Mac, but recently they released kind of half-working version for Windows. I don't really like it that much, at least not yet. I know, interface kind of bugged me. I really liked having tabs on top for some reason, but on the left, I guess one could get used to it. Maybe one gets a little bit more Windowsy. But just for the sake of stream, I'm not logged into all the personal stuff that I'm on my normal browser, so this way I can keep things separate, nice and clean. So let's make an iterator for iterating over all the changes. So I should need that, right? All I need to do is just literally call terminal, just draw, proc draw. Let's do that, okay? And this means that I can draw over a bunch of stuff. So let's do for, and we can copy the loop from somewhere here, where we do this thing. All right. So we go over every rune in the diff. We don't even do that. We just straight up do this, standard out, set cursor position to whatever we need to set it to. Style right line. Style right, okay. We'll just do that. We'll just do the styled right. And we'll be able to just keep doing things. Why isn't it happy? It's edit distance, scope distance. But that wasn't happy either. Let's just use the code that we had and then we can optimize it. Time elapsed. Let's ignore that for now. And sleeping, let's ignore that as well. Okay, we'll just draw the whole thing. Yeah, no Linux support yet. It's a weird browser. I'm not sure if you're missing out. The nice part about it is that you can make this sidebar to either be normal or just show up. And then you have on top kind of your tabs that are, always there. Even if I have this, I'll restart the browser. It will get back to the initial thing that I saved it with. So it kind of erases history here. And then below that, you have like your current browser tabs that are kind of temporary. You can set after how many days they just expire and they delete themselves. So that's that part. And you can also have multiple tabs with separate accounts, kind of like accounts in Google Chrome or something. So that's that. And the other things are that you could, let's say I can grab those docs and put them here on a side. And suddenly I actually in my browser have divided windows, or I could just divide this another right split and have, this show up here or not. Whatever. You can have like a tab which is multiple windows, multiple things open, which is kind of nice, but I haven't used it enough yet to actually utilize. And then you need to do the whole right click, separate all tabs, and ugh. But yeah, you're not missing out too much, I'd say. Just you can use the whatever on Linux, the some kind of nice window manager that will just do that for you with more features. You just need to learn more. Okay, so we've got that. We'll see if that will fail, but we should be able to print it out. And at the end, we want the diff clear. I don't think diff is new sequence. Okay, and this will be our draw. So that's that. So let's make those rights. Or not yet. So let's see how we're using it. Instead of this thing here, let's just grab this whole thing here and we'll just do draw. Okay, because we have that from the terminal. So don't complain. I just probably need to export it. Yep. Okay, now it's happy. And we just wait. Time elapse will be always 0, so we can just ignore that we have those changes so far. We can ignore our offsets. We can ignore the character delay, and we would need to render digits into the buffer. Okay, so let's not do that. We'll use rights in there. And we will need to specify the color as well at some point. How do I say color? Because I was printing out there. Okay. We'll get to the color again at some point. We'll just removing all the features just to see if we can do that. Standard out raise screen. We don't need that right now. Color index, we can ignore that as well. Display message, whatever, let it be there. And we'll ignore the hide cursor for now. And a whole display message. Straight up everything. Okay. Oh, geez, what the hell am I doing? So, in our rendered digits, I will ignore the buffer, right? Because we can use our terminal thing that we have. And basically for each line in there, we do that, and we need to set specific areas in the buffer. And we were using I for index. Seriously? For each line and each digit, if I mod time width, okay. Huh. This requires some changes. Let me think. So previously, when we rendered digits, we knew exactly what is the size of the buffer that we have. Therefore, we can kind of iterate over things and it just works. But here, basically for each line, we do this for each line, okay? So we have per line, so that's fine. Then we have the digit height. Yes, I do have a thing, and that goes to all the way somewhere up there into the constants. Yep, thank you for pointing it out. Okay, and I can just show it in here for now. Cool. Okay, so for each line of however many lines are the digits, then we do times string. Okay, I'm starting to think that instead of doing in this strange fashion, I could just make a method that just takes this, where do we have constants, that just takes the digit and just prints it out. It takes an array or like open array of lines and just shoves them in there. That could work. Yeah. I can see that working. So in our terminal, let's add one more thing. This whole draw could go somewhere all the way up here, because this doesn't have any requirements. It just prints out the buffer and that's it. So we have our writes that we'll get to. So let's do proc render. What do we call it? Render glyph. Let's call it glyph for now. So we want the position. So we do x, y, which was integer, and then will be our glyph, which will be open array of runes. No, open array of strings. Okay, because we have several lines. Okay, so that's that. Oh, but then we're gonna lose our nice scanning feature. Huh. Yeah, but our scanning feature was depending on not updating colors. Let's make it look nice. Let's make it like proper graphics thingy. Okay. And we just do that. And we do for each line a glyph. Our buffer.set. No, not buffer set. Oh, now we need to implement some extra stuff where we actually set lines to change. But okay. So for now, initially, we won't track colors, because then we need to also start tracking colors for each character. Foreground, background, and style. That will be another thing that we'll need to keep tracking. But for now, it's fine. So let's do it like that. For each line, we need to, in each line, we'll just do standard out, set cursor position to X and Y will keep increasing depending on which line, okay. And then we just do right. And now let's actually do our magical standard out right. And we just write that line, okay. This way you don't need to worry about any runes. But no, we can't do that because this is just, oh, I'm so silly. We're writing the buffer, right? I'm an idiot. Buffer.set. Now we have x, y plus I. And then we need to do, okay, so for R and line, okay. Oh, shoot. That's true. We were doing something where we got the runes out of it, right? So for each line, we have time string. For each line of digit height, for each digit in a time string, we're doing this thing. And for, okay, this is just adding the thing. And then we get the segment, which will be 2 runes, okay? So we get the line 2 runes. And then for each rune in a segment. Okay, there we go. So let's do segment or like runes is line to runes. Okay. For R and runes, type mismatch. I'll give you a type mismatch. To runes. Yeah, should work. So this is just being stupid. To runes. Okay. Oh, duh. Let. Oh, that makes sense. And then buffer set x, y, I, and okay, we need to keep increasing x as well. So let's do this as iy, and here will be, can I just do x? I don't know if we're gonna get that. Plus ix plus iy, and we give it the r. We just set this thing. And buff, buff, buff. We have buff here. Okay. Doesn't like it. Type mismatch. Let's see our set. Oh, our sets are probably still expecting the diff sequence. Yes, so let's provide it as well. Comma. Diff. There we go. So that should render the glyph. Yeah. Okay. So our right will basically. Oh, I just remembered in our draw. When we finish drawing, we need to do standard out flash file. Just in case, okay? And here, when we're in the glyphs, we did this bunch of stuff. While our right will be something very similar. We just get the runes out of our text and we just iterate over them. Oh, we need to specify where to write that line, huh? X, Y, which is integer. And then we have our text. Okay. And I'm not doing any over out of end of line or something. Not yet. We just wanted to make it work. And that's the Y. Okay. And this thing will be very similar, where we can basically this thing. That'll be interesting. So let's do var ix is 0. Okay. Now for each string, we will do basically this thing, but we'll be increasing the whole thing. Okay. So here we get the runes, which will be the S to runes. Okay. And then for ix, we do this and we set that. So we need again x and y. And we just need to keep increasing the ix. Yeah. Type mismatch. What the heck? This plus that. Oh, no, we should be good. Yeah. Strange. Oh, whatever. We'll see what happens. Oh, well, IX is declared but not used. What? We're using it right here. Whatever. Okay. So we have rendering glyphs and we have drawing. So I should be able to go here and instead for each line, I would like to just go over the glyphs, right? So we have the string, we have the digit, and there. Okay, so we don't need to go over lines. Okay, that's one thing. Okay, Nova has to go. You're the first NIM live stream I've seen. Keep it going. Yeah, there's not a lot of people who actually want to watch NIM, so I'm filling in. I'll have a great day then, because it's early morning back in Poland. Very early morning. 8 a.m. I believe. See you. So we have our digits. Then in times string, I can go over each digit. Okay, that makes sense because we need to print them out. And then over that, this is, let's not worry about spacing yet. We just want to go over each digit. And we don't need to worry about runes from the digit. We do digits and get the digit. Ah, that's how we get it. Okay, so we can do basically render glyph. I shouldn't call it render. We just, let's call it this, render, right? Instead of draw. Well, this should be draw glyph. Because in some way, rendering is like when you actually render and show it on a screen, while drawing is just drawing to the buffer, drawing, and then you render once. Okay. So let's fix that. And we had our render somewhere here. Render. Okay. And we're gonna do draw glyph. And now we need X and Y. So let's do X will be I times 9. Let's do I times 9, okay? Y will be 12 or something like that. And then the digit. We need to get the digits. So we do digits. Digit, okay? And that should be it. Okay, nothing else that's crazy. Nothing set here. We just draw the glyph. And bam. And one by one. Oh, I just need to remember to increase the I. That's it. Okay. That's how we can render the digits. If that's going to work, I'll be very, 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 very happy. Although it won't work with the... It won't work with the... whatever, the colon. There'll be extra space, but for now it's fine. So, time width, colon width, let's ignore all that. We can measure that later. Message, for now we won't gonna print it. All we want to do is we have our params, we calculate the minutes, start time, countdown time, and all that. And now we have our while loop where we get the minutes and seconds. we build a thing and we call render digits. And we don't need to provide it a buffer anymore. Okay? And after that, we just render and sleep for a second. And when we finish, we just ignore it for now. Let's see what happens. We don't even need the reference to a buffer. Awesome. Or to Unicode. Even more awesome. Okay. So let's see what kind of scary errors we're gonna get this time. Buffer.nym cannot instantiate buffer inside of type definition and the Buffer2D. Maybe generic arguments are missing. So it's still complaining about it. So buffer 9.8. I can control click it. Yes. Oh, duh. T cell. There we go. Now what else? Undeclared identifier color and terminal.nym. Where? Oh, right. We don't have the color. So let's copy it and we'll just comment it out for now. I will just print out the room. Okay, no color so far. We're skipping that feature. Now type mismatch 37.7. So one is integer. I'm missing something here. We have this defined here, right? Proc doesn't return anything. Equals. We create a variable, which is of type integer, I believe. Then we'll iterate over strings. We do this stuff. Oh, duh. That's what I'm doing. For each rune, we don't need that. Okay. That's where the error happened. And something was running. Let's try it again. Okay. Cool. Something's happening. And not this one. We want this one. Oh. No way. The first try, it actually works and prints our glyphs without any blinking lights. That is a success. Wow. Okay, that means that we can create our own font and just use that to print out whatever we want, however much we want. We just need to add colors and all the stuff and a million other things, but there is progress. Okay. I think we'll be able to specialize our buffer specifically for displaying stuff on a screen with colors and stuff and with all this generic stuff. Hey, this works. Huh. And that means we can easily create little things that will fill the parts of the what do you call it? Parts of the buffer with something and whatnot. Yeah. Okay. So that works. Before we add our colors back here, what we can do is go to the buffer. Oh, I'll need to finish soon. I think this will be the main project because I'm enjoying this way more than I'm enjoying working on the Common FS. I think I'm gonna just, when I have time, I'm gonna finish, continue working on Common FS silently until I have something to actually show. Because I have a few other things. I'm finishing one other video. So much video editing to do that I'm actually sick. Although I can show what I did so far if there is somebody watching. I don't know if there's somebody still watching. I can play a video. So let me do that. If somebody's watching, they will see it. If they don't, they won't. But it's my first time editing like a actual video from scratch. That's only a video, not a live stream, so that's new for me. Videos and the render number 3. I'm gonna place it here. Not this. This. Where did all that go? Okay. So that's the thing I have. This is max, so can make it full screen. Does it show us full screen? Yes. And you should hear the voice as well. It's just a 47 seconds? What the heck? It should be 30 seconds, so I'm not sure why, but a 30-second video. That's intro to the video. Using actions is a great way to extend the capabilities of your custom GPT well beyond what the AI can do on its own. Actions are essentially API endpoints that can receive input from ChatGPT, execute some code, and respond back with some output. Creating an API for GPT actions might seem complicated. Setting up a complex project, buying and configuring a server, dealing with a lot of HTTP intricacies, and so on. Fortunately, with Valtown, it's actually quite simple and totally free. In this video, I'll show you how to create a simple action for a custom GPT using Valtown, step by step.
Disclaimer. This article assumes that you can create your own GPTs. At the time of recording, that feature is limited to ChatGPT Plus subscribers only.
And that's it. So yeah, that took like 3 hours. But oh well. Alrighty, let's turn off the desktop audio. There we go. Bam. Cool. So let's just quickly edit the buffer. We don't want this whole T cell anymore. Okay, that's like not needed in our case. And this will be rune. Okay, it has data, that's rune. Just a bunch of runes. Then this doesn't need anything like that in here. This will be a rune. And this will be also a rune. And I think that rune will actually be replaced by something else soon enough. Okay, we have our diff entry, and Buffer2D doesn't need any T cell anymore anywhere. Just let's get rid of it all. Bam. Okay. Blah blah. New sequence and no time. Oh, because it needs to be rune for now. Okay. Huh? Everything else looks happy. Okay. Oh, because that suddenly needs Unicode. Import standard Unicode. Okay. And now I import. There we go. And rune. Rune. Where else do I have T cell? Rune. Everything is a rune. Okay, that works. So that made everything into rune. Let me just make sure that I can still use it. I don't need any of those here. And let's try to run it. Of course, I turned the terminal off again. Where is it? Here. Here. Okay, that still works. That's good. So let's continue and modify our buffer to actually not use a rune. We'll make it a pixel or whatever. What do we call terminal pixel? We'll call it pixel because why not? And that will be many things, I guess. Object, okay, and we'll have the foreground color, which will be color. Let's see what the docs say. Terminal. We have, what things do we have here? We have some types, right? Background color. That's just enum. And that's just values. 256 color, not supported, see enabled through color. Okay. Or foreground color. But we were able to put in any kind of color, huh? Style is one of those. Terminal command. Set foreground true color and set background true color. Okay. Huh. We'll see. So let's do something else. Foreground color will be string. I know, scary. Then we have background color will be a string. Style is what was the tile? Style. Okay. Let's just make those all available to grab. And then we also need the rune. Okay. And style. Undeclared identifier. Oh, because it needs to be imported from the terminal. There we go. We've got style. And now our buffer will be of pixels. Okay. Value is pixel. Pixel. Oh, that thing grows a lot now. Okay, wow. We've got hide, position to index, all that stuff. When we return a pixel. When we set, we need to set a pixel. And therefore comparison needs to be different, but this will be by value. So this should work on its own. Okay, that's good. Again, get and set. And that's it. Bam. Gosh, that terminal the buffer is so easy to work with. Now on the terminal though, it will be a different story. Render is gonna be relatively fine. We just need to get the color, right? So instead of rune, we'll have pixel. Because our diff, yeah, it's a pixel. So I'm gonna get the pixel dot foreground color. Let's just do pixel dot rune. That's gonna work so far. Okay. We don't do any character stuff, no sleeping. Huh. That's the rune. We need to specify. Okay. Huh. So simple right will basically. So I need to set another buffer where another set where we are doing something else. So that set will be here to do something like a rune. Okay. Data index and dot rune. Okay. So if all value is different than new, we do the rune. We set the rune and we add the whole thing here. Okay. That's interesting. So yeah, now we have that available. That should add changes to the whole thing anyway. That's good. And the same thing works here now. Okay. And glyphs will be running as this and that, and we just set this stuff. Will that just work? Really? It will just work? Yeah, it just works. Oh, wow. Okay. So that means I can tackle the colors easily? So the colors should be string. That means I should be able to set the color. So if I'll do draw glyph, have a glyph, okay, but I should be able to also specify the colors and stuff. Huh. Let's do it in a way that we can just specify the color and then we'll draw with it. So let's do somewhere up here. Rock. Set. F color. And we just give it a color, okay? And what's the type and color for nim? I'm sure we have something special for colors, right? Because we can get the, how do we do? ANSI foreground color, and that returns a string, okay? Foreground color code, and wait, what was the thing here of colors? From hex, and we just do that. Okay. Escape code. Okay, so that's the escape codes, and we assemble it by FG word. Okay. Okay, I see. FGBG. So how does that work? FG prefix, and that's the same thing. Just extracts it from the color. Okay. And for color, we can get somewhere. Okay. And let's see color. Color is in here. Distinct integer. Standard colors. Okay. I mean here. So that will be terminal colors from standard library. And therefore we can do set foreground color and we just give it a color. What was the type here? Let's just ANSI foreground color code. Okay. Let color code is ANSI foreground color code. Just give it a color, okay? And when we have a color code, we can code. So let's just add var current foreground color. Bam. And color. So let's do string and string. And this one will be set f color. And I can run it and oh, of course, because they depend on each other. Let's see. Color white. Okay. How do I do that? Color. Okay. Does it work? Color white? Yes. Will be see background color code, color black. And we just do current. Foreground color is this, and we can just straight up inline it. And the same for background color. Okay, so foreground and background color, they're like that. And when we're setting things, we should be setting that as well. So let's also do current style. Current style. And that'll be style. How do we do ANSI style code? Oh, string. Okay, sure. ANSI style code. And we do, that was the type here, right? Right, dim italic underscore hidden strike through. What's the normal one? Right text dim italics underscore blinking bold rapidly blinking reverse hidden text strike through. There's no normal. Let's give it 0. Style code. It doesn't say which one. Huh. Interesting. And there's a reset code that's like straight up everything resets. Okay. The current style, this and that. And we can do proc set style. And we just do that. There we go. So in theory, it would be better to just, yeah. So let's do like the current style will be type style. Style. Okay, and we just do 0. And it won't be happy. Shoot. Style bright. Sure. There you go. Whatever that is. Set style, and it will be just style. Okay. So when we write things, we have text, we can assemble the pixels. Let pixel is pixel, and we have, what do we have here? And the pixel to set in our buffer. We can say FC will be current F color, current background color, style is current style, and rune is R. Okay. Yeah. And we just give it a pixel here. There we go. The same thing will be basically here. And when we draw the glyph, we also need to set the pixel. Yeah. So let's try it without setting anything. It should just work. I hope. Let's run it. Yep, it just works. But that means that now I can actually bring back the fun stuff. Huh. Let's hide the cursor in the meantime. When we ended our Buffer2D, we are also going to hide the cursor because that's like a good stuff. Okay, and we have parameters, all this stuff. Display message, let's do color index -1. Then we do the color selection, get the color index, and the color will be what? Let's go to our colors here. And our palette is basically those codes like that. Oh. Huh. That means that we should also have variants of setting our terminal colors to already existing escape codes. Or we replace those with like proper colors from standard library. That could work. Dum 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 dum. So let's get to something like color. We're gonna color code, and we set if bright is true or false. Huh? Another weird thing. How is that implemented? Style ordinal of FG. We're gonna color. That's the style. Increase style, but what the heck? Huh. Okay, I see. We're gonna color code, and it just takes the foreground color. Okay, that's why. Okay. But if I'll get the color, how do I make the color? These are just constants. Don't want that. extract RGB, intensity, parse color. That's probably it. Parse color. Yep. Parse color. And we need to get colors from here. Okay. Good. That means we are not using this one anymore. Sorry, drunken alcoholic. Okay, we've got our color palette. Okay, we get our color. That means that we can just straight up already set the color. So we do the set foreground color to color. Okay. Render the digits. And what do we have in the rendered digits? Just the stuff here. Yep. Draw the glyphs. And we just go on and we update the colors. Hey, that might just work and colors will work. Nope. Hex color to escape code and countdown nim. 717. Oh, okay. We don't worry about that. Run and color and countdown nim. Line 39.3. 39.3. Well, countdown is this color selection. Like what? Oh, because we had what was a comment? Somehow it became not a comment. Set foreground color. So what do we call it? Set F color. Okay. Well, it prints stuff. It just doesn't print the color. But that's because we haven't implemented that yet. So we will basically do pixel dot foreground color and combine it here. Okay, and that means we can rerun it. And now it works, but that means we'll also need to be setting the background color and the other stuff. And that will be a lot of printing. Pixel dot background color and this and style. I guess I need to calculate the style. ANSI style code pixel dot style. It's gonna be interesting. Whoa, and background color set. So I guess we could also not set the background color so that it stays the default. How do we get a default? That's a good question. But these will be questions for next time. Because, gosh, this looks so good. Huh. But yeah, these will be questions for next time, as I'll be finishing because it's really, 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 really late here. So thank you for watching as always, and I invite you to like and subscribe, follow on Twitch if you're watching on Twitch. And hey, feel free to write in the comments now that video has ended. And see you the latest on Wednesday.